Namaskar, good morning and welcome to CIET NCERT's another live and interactive session, Virtual Labs. My name is Deepak Mishra and you are watching this Virtual Labs live session on PM eVidya channels 6 to 12. And apart from that, you can also join us on our YouTube handle by the name NCERT Official and NCERT PM eVidya class 6 to 12. Before starting this session, let me give you a brief idea about virtual labs, that what actually virtual labs is all about and how the students, how the users can get benefit about it. So basically, giving a brief idea about virtual labs, it is a laboratory. Virtual labs is a digital simulation of a physical laboratory that allows users, that allows learners to perform experiments, explore scientific concept or practice technical skills using a computer or device. And let me give you some key features about virtual labs, that if you are a user, if you are a learner, so what you get interactive elements like dragging, clicking, some virtual tools, step-by-step guidance, interventions, data collection and analysis. And one more benefit which you get is, in the lastly, you have an assessment to conduct. There is a quiz and this will gonna help you definitely. So let me give you now about the topic and subject idea. Today we will be studying and experimenting about class 10 physics subject, and the topic is demonstration of simulation on reflection of sound in concave mirror. So we will study a lot of things and it will be gonna really interesting session on virtual labs. So during this entire session of virtual labs, if you are a user, if you are a learner, and if you want to connect with us, reach us, or if you want to ask any question, you can reach us by calling on number. The number is displayed on screen. It is 8800440559, and apart from that, you can also reach us by writing an email. We also do have a dedicated email ID. The email ID is diksha.training@ciet.nic.in, and apart from that, during this entire virtual labs live session, you can go to our official YouTube channels by the name NCERT Official, and in the comments section, in the live chat box, you can ask your questions, you can give your suggestions, and you can connect with us. So without getting delayed, now let me introduce all of you with our special guest who had joined us in the virtual labs today's session. We are joined by Dr. Uma D. Sharma ma'am. She is academic consultant in physics, CIET NCERT. Uma ma'am, very good morning. Namaskar.
Namaskar.
Ma'am, I'm very excited about today's virtual lab session, and what what new experiment we will be doing today, what all new thing we will be learning today, ma'am.
Yes. As you have already mentioned that we are demonstrating the reflection of light using a concave mirror. So, before starting this session, let me introduce a very brief introduction of mirrors.
Right.
Like when you came here from the morning, everyone has seen mirror while coming over here, right?
Right.
So, normally when we get ready, we see ourselves, and what happens exactly, the image which you see in front of a mirror is simply the reflected rays which are getting reflected, bounces back from the reflecting surface, right, and the size of the image is same as the size of the object. So, this is all because of the reflection of light. You can see yourself just in the same size because of the reflection of light, and normally this kind of mirrors are plane mirrors which we usually interact with daily, right?
Okay.
Now today we are discussing about concave mirrors. So what are the concave mirrors? So let me give you explain you about this concave mirror. Like, it is a mirror which is a like concave, or you can say that it is converging mirror because it converges the incident rays to a focal point, and this feature makes it unique for this making this images, right? So let's start with the experiment.
So ma'am, my question is that it is very interesting, and till the time when I had seen a lot of sessions on virtual labs, today's topic is very interesting. It seems to be very learning and interesting. We will be learning a lot of things about concave mirror. But if a user, if a learner is watching us in this session, how to reach us? Can you please help us by navigating this?
Sure. So first of all, you should go to diksha.gov.in, and here you will find various focus area of Diksha, and among this focus area you will see that this virtual lab. Under this virtual lab you will find all the content from grade 6 to grade 12, right. And here this is a class 10th experiment, as we know that, and which is available in Hindi and English. So, you will go to English science medium, and it is a experiment number 35, because this is aligned as per the NCERT. So, here you will find the experiment number 35. So, simply I just open it. I have already opened it. So, I just share that thing. This is a 35th experiment, okay, which is a to study the reflection in concave mirror and observe image formation for different position of the object. Okay. So, this we will learn over here, and see, it has a unique applications in many field, varied field, like for a torch, for telescope, for solar cooker, because at the focal point it is all the heat is incident on the concave mirror, and that concave mirror and at the focus the temperature increases. So, which this it is used in a form of a like a solar cooker, right. And so, let us start with this experiment. Okay. Now, before going further, you should know about the basic terms to understand it. First is reflection. This concave mirror, as we have already discussed, it is a bent in surface. It is a spherical mirror in which reflection of light takes place at the concave surface, and pole is there. This is a central part of the mirror, and focal point is that point where the entire rays which are coming from the infinity are focused at this certain point, right. C is the center of curvature, because it, like if you imagine this part as a big sphere, it comes out to be hollow sphere, right? And C is the center of it. So, that is why it is called center of curvature of that particular mirror, right. And this is a very important property of a concave mirror. And principal axis, the axis which passes through the pole, focus and center of curvature. Next is laws of reflection is there. So, see, as we know that this concave mirror also follows the law of reflection, which states that whenever light is incident on the surface, it reflected back to the same medium. Okay. And whatever angle is there at the same point, at the same angle, it is reflected, bounces back to that particular medium. And since it is a curvy in nature, the unique feature is, normally in plane mirror what happens, the size of the image is same as the size of the object, okay, nothing changes. So, and you will get a simply virtual image, but in this case the nature of image changes. It will be a real as well as virtual, based on the condition of the object where it is placed, right. So, as I already told you that it also follows the laws of reflection based on the angle in which it is incident. The angle of angle of incidence is always equals to angle of reflection over here, and the incident ray, reflected ray and the normal at the point of incidence all lie in the same plane, right. Now, as I already mentioned that the two types of images are formed, real image and virtual image. In both kind of images are formed in this concave mirror. Only this is the mirror in which both kind of images are formed. So, I will just show you a brief. You can see it over here, like you can see that when the object is placed, different conditions are there where on placing the object and how the image will be formed. Okay. So, here we will learn, we will on by simulation, that how the image will be formed at various position of the object. So, before going further, let us see a small video which is available over here at reference section. At reference section, just let us see a short video. Okay. So, how the images are formed? To understand how the images are formed, we need two rays are required. The minimum requirement is two rays, and ray diagram is basically simple to understand how the image is formed, because we cannot see light, we cannot imagine how the object is formed, we can interpret it in the form of rays. Okay. So, two rays are required to obtain the size of the where the image is formed, right. So, see, whenever a light ray passes parallel to the principal axis, it always passes through a focus. It always passes through a focus. Whenever a light incident at pole, because it acts as a normal, because whatever this line acts as a normal, so it reflects back with the same angle. and when the light ray is parallel to the principal axis, it passes through a focal point. So, this is the three basic scenarios are there, and based on it we will simply make the images formed, right. So, one by one we will discuss it. You can see this as a parallel, it passes through a focus. When it passes through a focus, output is it reflected as a parallel to the principal axis and here. Okay. Now, let us move further. Let us move further. Now, we will go to simulation part. Here, as we have already opened this simulation. Okay. So, before going to simulation, let us understand little bit about the procedure part. See, what is a basic requirement? We require one concave mirror, a mirror holder, semi-transparent screen is fixed, which is there in the physical lab is required. Okay.
Right.
But right now we are doing virtually. So, simply we will go to the simulation part. We will go to the simulation part, and here you will find this kind of setup is there. This is a concave mirror, right, and this line interpret that it is a non-reflecting surface, and this concave, the inner part is the reflecting surface, right. You can imagine, the student can remember this, that you are entering towards the cave. So, concave, entering towards a cave, because many times students forget what is concave and what is convex, they get mixed up things, right. So, this is a easy way to remembering what is concave. So, reflecting, the inner reflecting surface is concave, just like a spoon in the inner side of the spoon. Okay. Now, how the image will form? Here the three options are available: show help, show raise, show label. So, one by one we will click show help. Suppose the student doesn't understand what is where is the object, where is the image. So, show help will provide the this nomenclature over here. Move the object position by dragging the point object and locate the image at the point image. So, this is a help thing. Now, we want to see raise also. So, I will click this raise part also, and I want to see label part also. So, I will put this tick mark on the show label also. Okay. So, I will just remove this show help part and other show raise and show label only. So, it will make a more clear scenario here. So, this is the object is here, the mirror is here, this is a behind the mirror part is here, and if you already have here, they have enlarged this concave mirror, and it comes out to be a hollow sphere. Okay. The hollow sphere of glass, and C is the center of this glass, which is called center of curvature. Now, we will start this experiment, right. So, first condition we will take it, you simultaneously see the instructions are given over here, click on the next icon to show instruction, other part is also mentioned over here. Simultaneously, I will show you this observation table as well. So, what are the condition when it makes a virtual image, what are the condition when it makes real and inverted image? That is a very important thing to understand, because accordingly it is used in a application, right. As I already mentioned you, there are several applications are there, like dentists use this kind of mirrors, okay, to get an enlarged view of teeth. Then it is used in solar cookers, then it is used in an optical instrument like telescope and microscope to illuminate the stars and other things, right. So, it is very important. Now, here one by one we will go through this experiment. Now, what first position, object position is between pole and focus. Now, between pole and focus, that means when I keep the object between pole and focus, between pole and focus. So, how image is formed? You will see that the image is upright position, that means it is magnified and it is virtual. See, the student can experiment themselves like simulating this, which is a very nicely it is showing how the image is formed. Okay. So, how the image is formed? It is virtual image. So, we will write it over here, observed image position, where the object image it is behind the mirror. So, I will write the behind the mirror, and it is magnified. I will write the observed image side as magnified. And what is the nature of the image? Nature is virtual and erect. So, all these three observations are I have completed over here by seeing this observation part. So, this is a very like at the same time they can view also, they can write their observation also, right. Now, next we will do the second part, that is at focus, how the image is formed. Now, you can see that at the focus I will place the object at focus, I will just drag this to focus point. So, I told you whenever the object is at focus, the rays will be reflected to the infinity.
Okay.
Okay. So, that is why this application is used normally in torch and this beam lights like in, cars headlights. Okay,
Right.
because the small source is kept at the focus and all the light is reflected to the in a parallel beam and gives a very strong beam, right. So, this is one of the applications. So, it keeps at the focus, image is formed at the infinity. So, what again I will do, I will write the observation over here, where the image is, where the observed image position, it is at infinity, I will write infinity. What is the size, observed image size? So, since it is at infinity, so it is very diminished, and how it, because real and inverted, because when it the image is formed on the same side of the object, it is always real and inverted.
Okay.
Right. Now, next come to the third observation, between F and C, that means when the object position is between focal point and the center of curvature. So, what I will do, I will keep F, drag this object between F and C. Now, you can see that the image formation is inverted and real, inverted and real, plus it is little bit magnified also, it is not of the same size, it is magnified also. Okay. So, this is our observation. So, I will again we will write over here what is the observed image position, it is between C and F, this is between, you can see this here between C and F, no, it is not between C and F, it is beyond C, it is beyond C, beyond C. Then what is same size? No, it is magnified, and which kind of image is formed? Real and inverted.
Okay.
Next at C. So, this is a very important position, because here only the size of the image of the object is same. When I place the object at C, you will get the exactly same size of the image, and but it is inverted, right. So, see, this is a very fun way to understand how the image is formed in the case of a concave mirror at the various positions. So, at the center of curvature, always the image is of the same size as of the object, but it is inverted. So, what I will write it over here, okay, the image is at C only and same size as the object, observed image size, and which kind of nature is, it is real and inverted, right. Next is beyond C. So, what will happen when it forms beyond C? Now, I will place this object beyond C, and you will see that the size of the image is diminished now,
Right.
and it is of small size, and it is inverted, So, I will write it here, this beyond C, it is behind between C and F, and it is diminished, and here see, you can also do it,
Right.
real and inverted. Now, next submit. So, once it is submit, here it is at infinity, it is magnified, sorry. So, this activity is completed. Okay. Now, once the activity is completed, student understand how the image is formed, how the at what is the positions of the where the object is placed, so that the image is formed virtual or real. So, you will see from this table that only at one position, which is between pole and focus, the nature of the observed image is virtual and erect. And the beauty of this table is that if I place it something wrong, like here I have selected diminish, so activity is not completed at that time, right. So, it will immediately rectify your where you are wrong. So, this is the instant feedback you are getting while the assessment part. Okay. Next is, once this experiment is complete, student understand the reflection of light by the concave mirror and what are their application, why they need to study it, they can go for the Viva self assessment part. Okay. So, this is a self assessment. So, one by one they can do this, the entire questions, the what is the parallel beam of light falls on a mirror, all the ray of the beam after reflecting actually intersect a point, and the mirror is which type of a concave mirror. Okay. So, in this way they can do all the question and submit it, and they can get the feedback also whether it is correct or not. Like I have not attempted here. So, it is showing cross and this portion is correct. So, this is showing the correct part.
Okay.
Right. So, instant feedback, here you can see that the instant feedback is there whether they understood it properly or not. Then one more icon is there, this is reference point. From there only I have shown this video, okay, which explains the formation of image by a concave mirror, okay, how the rays, what kind of rays we have to use to make a this ray diagram for the concave mirror for the reflection part, plus other tutorials are also available. You can see that other things are also mentioned, like physics tutorial is there, these are the other links are also available where the student can go and see what are the things which is they need to understand it. Okay. Then there is a feedback form is there. So, after they can give their feedback also, like which part is correct, which part is not correct. So, in this way we can see that the entire experiment is very well explained over here, and during with the help of this simulation we can do it any multiple times, multiple number of times the student can do this experiment without hesitation of whether it is they are doing correctly or not incorrectly. They can do this experiment at home also. So, virtual lab gives this kind of availability that at 24/7 they can do this experiment anytime, anywhere. They only need a internet connection, stable internet connection, and they can do this experiment effortlessly at home also, and they understand the reflection part, what is the reflection concept, what is a concave mirror, how they are different from the convex mirror or plane mirror.
Ma'am, I think you had beautifully explained our viewers and our learners that what actually they can go ahead and perform in the Diksha website by entering, and especially the second last column where is the reference, they can watch the video as well, and they can understand that how actually this complete process work. If there is an object and if you place a concave mirror in front of that, what actually the process is all about, how do they perform. They can have a practical as well, and apart from that they can also conduct the assessment, the quiz in the last after understanding the complete process. So, I think it is very easy for the learners as well.
Yes.
So, in today's session we had learned a lot of things, and Dr. Uma ma'am especially helped our learners and our viewers to understand the complete session in virtual labs on our today's topic on physics subject, that is the demonstration of simulation on reflection of sound in concave mirror. You can go ahead, you can also understand this by watching the video, by doing it practically or virtually by entering the website, and in the last you will be watching the assessment. The quiz is also there, you can go ahead and just take a part in the quiz. So, I think today's virtual labs session was very amazing, very interesting, and of course a learning session as well. Now lastly, Dr. Uma ma'am, I would like to thank you so much. You came in this session and explained so beautifully.
It was a pleasure. Thank you.
Alright, so dear learners, you can go ahead and just visit the Diksha portal, and the basic procedure, the details we had already shared with you in the starting of this session, how you can go ahead and just do this experiment virtually. So, it is very helpful, learnful, and experimentful too. So, announcement before wrapping the session, now the students go ahead and purchase the textbook of class 4 and 7 online on Amazon, Flipkart, and of course on our official website, that is NCERT official website. Now let's have a quick look on the upcoming sessions, what all sessions you will be watching today on PM eVidya channels. After some time at 11 AM you will be watching our weekly session Ullas, Foundational Literacy through Critical Life Skills. After that at 12 PM you will be watching a session on class 11, subject will be English. Topic is The Lament on inclusive classrooms. After that at 2 PM you will be watching a session on class 5, subject is English, topic is My Shadow. After that 2:30 PM you will be watching session on class 5, Subject is Hindi and topic is Daki ki Kahani, Kamar Singh ki Zubani. At 3 p.m. the subject will be science and topic is exploring magnet. At 3:30 p.m. you will be watching special session on subject mathematics. Topic is number play part 1. 4 p.m. you will be watching our online training program on eVidya class 6 to 12 channels, and lastly you will be watching our special session on Sahyog. The topic will be recognize and address the feelings of loneliness and isolation. So this is me, Deepak Mishra, now wrapping up with this session. With the commitment, I will come back once again with another guest. We will be learning a lot of things in virtual labs, and apart from that, a lot of sessions are going there. So till the time, take care of yourself, keep smiling, keep learning, and keep watching PM eVidya channels. Namaskar.